We are now live on YouTube, so we are ready to get going. Welcome to, we'll still give people a few more minutes to get here. We still have a minute. So started us a little early. My apologies, everybody.
That's okay.
All right. Okay, so we are up on YouTube. We are ready to go on the webinar. For those who are joining on Zoom, feel free, as you are already doing, to introduce yourselves and where you are from, which is tradition at this point. It's kind of nice. I really like it. And don't forget as well, if you're joining on Zoom, to change that the little thing that says panelists to panelists and attendees if you would like to talk to everybody. It looks like we're gonna not have very good weather for the next couple days, unfortunately. Or at least for tonight, eh, Chris?
Yeah. Well, today's forecast is, if you look at the astronomer's tool, it's blue square, gray, blue square, gray square, blue square. So it's sort of variable, but rain tomorrow. But I went out last night and I finished the Isabel Williams Lunar Observing Program.
Well done. Oh, yeah. Good for you. What was your last object?
I got ready to go out about 9 p.m. and I walked outside. It was cloudy. And I thought, oh, it's TV night instead. And so I watched an episode of something, and then I was just getting ready to go and look at something else, and I saw the moonlight shining in the backyard, and it was perfectly clear out. So I felt, do I get up the gumption? So I said, all right, I'll do it. So it took me about 25 minutes to get everything set up, and then I spent till about after 12:30 catching the rest of the objects I needed. So it was great. It was good. No bugs, no mosquitoes. It was warm.
Oh,
fantastic.
That's the dream. Just for those who do not know, the Isabel Williamson Lunar Observing Program is one of our observing certificates. It is for people who are really good at looking at the moon. We do have an introductory one called Explore the Moon, which we're going over right now in a different show on Thursdays at noon Eastern time. And this Isabel Williamson one has, like, how many objects, Chris?
It's 135 regions, and within each region there's a simpler, easier aspect to view, and then there are some details that you could attempt to view as well, optional ones. Wow. So it's really cool. I really highly recommend it. You don't need to be an expert. You just need to have a good kind of an atlas to help find your way around. Mm-hmm. But you'll learn a lot, and you'll realize you'll see a lot of really cool things you never realized were wrong. So I highly recommend it.
Oh, that's nice.
Speaking of the moon,
we are going to be starting off with what's happening tonight / tomorrow morning.
That's right. So everybody by now has heard the news that there's going to be a solar eclipse on June 10th, thanks to many of Jenna's public service announcements, which are fantastic. But what you may not realize, and that is really cool as well, is that each solar eclipse is accompanied by a lunar eclipse and vice versa. And that's because eclipses occur when the moon and the sun end up close to the location where the ecliptic intersects the moon's orbit, which is tilted by 5 degrees compared to the ecliptic, roughly. And so there are 2 spots in the sky where they intersect. I can demonstrate that in stellarium in a minute. And as long as the sun and the moon are within about a half a degree, because they're each extended objects, then you can get them crossing in front of each other, or the moon crossing in front of the sun, or the moon dipping into the Earth's shadow. And so preceding the solar eclipse on June the 10th, we have a total lunar eclipse happening tomorrow morning, Wednesday morning, and it's visible across wide stretches of North America. Let me just bring up the picture here.
While you bring it up, I will also note that many news outlets, social media posts, etc., are saying May 26th. It is May 26th, but it is May 26th before sunrise, which for a lot of people, and me included, I do this too. When you hear May 26th, you go, okay, May 26th in the evening. That is not the case. It is May 26th in the morning, which is why I like to say May 25th in the evening. And this has haunted me ever since a deadline misunderstanding with a group work partner in university.
Yeah. So I love these diagrams that are produced by Fred Espenak. He works with NASA to produce these kind of diagrams for every lunar and solar eclipse. I'm going to share his website link in a minute here so you can see where that is. It's called eclipsewise.com. In fact, Jenna could put it in the chat for us. And these diagrams, you know, they look a little bit complicated, but really let's break it down for you. Basically, if you live in the dark shaded area of the world, you won't see any of this eclipse happening. And if you live in the white part of the world, you can see the entire eclipse. And anywhere in between, you get to see different aspects or different stages of it. Let me just bring up the diagram that goes with this one. And I'll just share what I mean by that. Okay, eclipse-wise. I'll bring this up.
And I just sent out eclipse-wise in the chat as well.
Let's do lunar eclipses. Here's eclipsewise.com. So you can see that there's a section for solar eclipses, for lunar eclipses, and other things as well. So under lunar eclipses, you can scroll down and he's got these cool diagrams and you can look for our year. So we've got May 26, 2021. Just click on the diagram and then you can click on that diagram and you can get the idea. So what happens is the moon is traveling in its orbit, in this case from right to left. And as it passes into the Earth's shadow, which is always there in space. We talked about the Earth's shadow when we discussed satellites a few weeks ago.
Oh, yeah.
When the moon dips into the Earth's shadow, then it is not receiving as much direct sunlight. When it's in the gray, the light gray zone here, this is the penumbra. It means that the Earth is blocking part of the sun. So the moon will get a little bit darker, but not completely dim. When the moon crosses the boundary here into the dark reddish circle here, that's the umbra, and anything inside the circle in space will be in darkness because the Earth will be entirely in front of the entire sun. And so once the moon starts to cut into this umbra, that's when you start seeing the bites out of the moon more noticeably. When the moon is in this penumbra, if you're really sharp-eyed and you've got good sky conditions, you might be able to detect that the moon is dimming slightly. But when you get those bites out of the moon, that's when it's really passing through the umbra. And this eclipse is going to actually ride through the north half of the Earth's shadow. In fact, it's barely total eclipse. It's just going to be, I think, 1% of the moon's diameter inside the edge of the umbra when it gets to totality. Now, tomorrow is also a supermoon. The supermoon, by definition, being the moon within like 90% of its closest approach to the Earth, so it looms larger in the sky. And when the moon looms larger, it's bigger, and therefore it's harder to fit inside the umbra. And so because it's a supermoon, that's why it's the totality, that the time in which the moon is completely in the umbra, without a little bit of a sliver showing, is only, I think, about 15 minutes of that time. Mm-hmm. So you'll see the moon get darker, 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 then it'll be completely dark and reddened for 15 minutes. The reason that you get the red color is because the only light that can get to the moon during totality has to pass beside the Earth. And what's around the Earth? The atmosphere. And what happens when the sun is shining directly along the horizon? You get red sunset light. And so if you were standing on the moon during a total lunar eclipse, and hopefully some of us will be one day, you'll see a reddish, glorious halo of the Earth's atmosphere glowing with this red sunset light around the edge of the Earth. And that produces the only light to get to the moon is reddish and gives it that quote unquote nickname blood moon. So the May moon is a flower moon or milk moon. There's another number of other names. The eclipse moon, they call it a blood moon. It's a super moon. Astronomers don't really like supermoon, but we you know,
technically
can't beat them, join them.
Yeah, so, technically that's what I mean, like it's the biggest moon, so.
Yeah. So you'll see on the news that it's the full blood flower supermoon eclipse. That the astronomical term for it is a lunar perigee syzygy. So a syzygy is when three objects are in a line. Perigee is when the moon is closer to the Earth, it's bigger. So that's what gives it the super. And lunar perigee syzygy. So that's a total lunar eclipse. So let's just show it on Stellarium.
And while you do that, Stephen Dow asked, do eclipses only happen during a full moon? And for lunar eclipses, yes. They only happen during a full moon because the moon has to be on the opposite side of the Earth from the sun, which is what a full moon is. It doesn't always happen on every full moon because its orbit is a little tilted.
Yeah, I'm going to show that here in a second.
Okay, sweet. And then
Yeah,
solar
so
eclipses always happen on a new moon. Okay,
if
sorry.
you go into Stellarium, you can set up some cool things. You can turn on the circles for the Earth's umbra and penumbra. This is under the markings tab. And you can also put on the anti-solar point. So this is the point in the sky that's exactly opposite the sun in the sky. So I'll flip those on. And then I'm just going to advance the hours here into tomorrow morning. And this is based on Toronto. And I'll talk about other locations here in a minute. Let's just advance. Let's just pause time. And we'll just advance into tomorrow. And so here we go. You can see that here's the full moon after it rises tomorrow morning. We'll be heading this way. And if I grab the moon and I turn on the orbit of the moon, which you can go under solar system and show orbits, then you can see that the red line that's the moon's orbit is a 5-degree angle from the yellow line, which is the ecliptic. And so if the moon is full when it's near the place where they cross, you get a lunar eclipse. But because the moon, the Earth is big and it has a larger shadow, then it doesn't need to be exactly on the crossing point. It can be within a short distance of it. So every hour, the moon will be traveling further to the east. So if I hop hour, whoops, let me just go back and center the moon in the view here. There we go, keep it in the middle. So there's 11:40, 12:40, 1, 2, 3, 4. So around 4:45 or so, the moon will start hitting the penumbra. And then as time goes by, the moon is going to set for people in Toronto. So what I'm going to do is I'm going to actually turn off the horizon here and keep it going. And Stellarium distorts the horizon so I'll turn off the daylight as well. So around 5:45 a.m. is when the moon will start contacting the penumbra. And at that point, you'll see the moon start getting the bite out of the edge of it. So if you live in Winnipeg or Calgary, Edmonton, and out to the West Coast, you're going to get, the moon won't have set yet for you. So then you'll get more and more of the eclipse visible. So that was indicated in that diagram where those gray strips, the further west you were, the lighter color the strip was, meaning the more of the eclipse you get to see. Mm-hmm. So by the time we get to around, and I'm using Stellarium still in Eastern time here, so you'll have to adjust it for your own time zone. But you can see that the moon enters the totality around 7:15 in the morning is when it'll be total Eastern time, but it'll have already set for Toronto. Mm-hmm. So that would be
4 a.m.
6, 5, 4 a.m. depending on where
15.
you are.
Yeah.
And then it lasts for 15 minutes total, and then it'll start creeping back out of the shadow again. And there we go. So that's how an eclipse works. And that's why, and if I were to sit here and use Stellarium to fly or to travel north and south across the planet, you can see how the geometry varies depending on your location. That's why you need to use a diagram like Fred Espenak makes, or a Stellarium or a Sky Safari app or something like that to do that. When we get to the solar eclipse, I'll show you a cool Google map you can use to find out where it is as well. Now, back to what Jenna was saying about the idea that they miss. So if I go back in time here, just go back. So back to totality. So this is now today, so May 26th. If I go back a month ago to last full moon, oops, let me need to turn these on. Do that, do this one. So let me just do this, advance my time here. Let's see. So I've got a few of these set up. Which one is it? Oh, that's the eclipse one. Where's my April one? So here's today. Here's a month ago. And the moon actually misses the Earth's shadow. So it was north of it. And then, yeah, go ahead.
When you turned on those two lines, that like umbra and penumbra, did that also turn on the shadow within those lines? I guess it's always there. The shadow's always there.
No, they don't need to be enabled for the shadow to show up.
Right, okay. So that just visualizes the shadow. And if it's going to be in the shadow, then Stellarium will show you that.
Yeah, yeah. And this is a great way of demonstrating, you know, how you missed it. If I go ahead into June, so the May moon will hit the shadow, but the April one missed it above and the June one will miss it below. All right, let's go to 2 weeks later. Now, because the moon is full near the node where they cross, 2 weeks later, the moon is new. It's at the other side of the nodes where they cross again. And so that's why you get a solar eclipse.
I have an animation showing that, which will drop on social media later.
Why don't you show it now? I'll just stop
Okay.
sharing for a second. Oops. Cancel that, and I'll stop my share.
Okay, so here is the alignment during, oh, that's a lie. It's at the there we go. Here's the alignment during a lunar eclipse where sun, earth, moon, and the moon's orbit is tilted so that this little sort of transect here lines up with the larger orbit of the earth. And then in 2 weeks' time, it'll travel around the rest of its orbit. This angle will stay more or less the same and it'll line up perfectly with the sun, but between us and the sun, which is what our solar eclipse is.
Very cool.
Okay, thanks. I spent a really long time on that. I appreciate you all watching.
All right. Now, there's another cool aspect to all of this. Let me just share my screen again. Here we go. Because tomorrow morning is a supermoon, the moon is at perigee, closer to the Earth. In 2 weeks, when the moon is new, it's also at the other side of the moon's orbit, and it's at an apogee. So the moon will be a mini moon in 2 weeks. So when you get a supermoon, will be alternate with an apogee moon, a mini moon. So because the moon will be a mini moon, when it crosses the point where the orbits pass at the solar eclipse, then we do not get a total solar eclipse. We're going to get an annular solar eclipse. An annular eclipse means that the moon is not big enough to completely cover up the sun. So this is the circumstance of the moon at, in the pre-dawn, about 5:40 a.m. in Toronto. Let me just bring up the horizon again here, and I'm just going to tilt things back, and I'm going to make my horizon a flat one so we can see the landscape. 0. There we go. So if you get up before dawn, check the alarm first on June 10th.
Oh, yeah.
Check the alarm first, make sure it's going to be clear, and get up early. And yeah, and then this is what you'll see from the GTA area. So right after the sun rises, the eclipse will be halfway done. The moon will be already finished covering up the moon to the sun to about 80% or so. And then if we advance the time beyond, the moon and the sun will climb in the sky because they're rising in the east. At the same time, the moon will be departing the sun. So by the time we get to around 6:40 or so in the morning, the eclipse will be done. So that's the morning of June 10th. Now, let me show you the path of this eclipse. Bring this one up. Here we go. Get rid of that one, and I'll bring up, here we go. So here we go. This is the diagram from Fred Espinac, and it's showing you that the dark red band here is the zone where you'll be able to see the moon entirely within the sun's disk, so the annular eclipse. So there is no totality for this eclipse. There would be no moment of this eclipse where it's safe to look at the sun, because there'll always be a bit of the sun visible at every moment during this eclipse. And the way this diagram works is that here's the Great Lakes region here. So the moon will move into the space between the sun and the earth. And at some point, the moon's shadow will then touch down onto the earth's surface, and it'll speed north. So the point it makes contact is in northern Ontario. Then it'll speed northeast across Hudson Bay, across northern Quebec, almost straight over the North Pole of the Earth. And then it'll start heading south into Siberia, and then it'll lift off again on the other side. So all of the rest of the sort of the diagram, the grid that's on here, indicates where you can be living and see part of the eclipse, but not the totality path. So that's the way that works.
Before we
Again,
get too far into the solar eclipse, there was a question from Stephen Dow, which was, what is the name for when the moon starts going into the shadow and when it comes out of the shadow? I know when it's the sun, it's first contact and like fourth contact or third contact, something like that. Do you know if the moon has one?
Well, most of the time astronomers use the contact phrase.
Okay.
So we see there's these umbra contact, penumbra contact. So we would call that kind of U1. And then when the leading edge hits first, that's U1. When the rear edge hits, that's U2.
Okay.
And then when the leading edge is exiting, that's U3. And when the trailing edge is exiting, that's U4. That's not counting for the fact that that's counting. So to pick an umbra and do it for that. So the umbra will have 1, 2, 3, 4, and the penumbra will also have 1, 2, 3, 4. It's easier with the solar eclipse because it's basically when the moon first bites the sun, fully covers, then finally leaves the sun's disk. I'm not sure that answers the question. I'm not aware that there's a special term for entering and exiting the umbras. But if there are, folks can share that with us. All right, so let's see. I thought what I'd do then is, let me just wind this back. So that's the circumstance in the Toronto area. What we can do is we can actually simulate for people how the eclipse will work at different parts of the country if they're interested. Let's see, we can close this one up. So let's say we go back to roughly totality, and we just pick up. Let's do that, and we'll pick up. Let's say we pick Winnipeg for an example. So Winnipeg, we'll see the sun. The eclipse will be further along. So the further west you are for the lunar eclipse, the better you are. But for the further west you are for the solar eclipse, the least, the less of it you'll see. So really what you want to be is in the Maritimes. That's where you'll get the better show, or northern Quebec.
Or Baffin Island, if you happen to be there already. Not where you should not travel there, because we're in a pandemic. But if you're already there, it's a good view.
Yeah. So here's Montreal.
You're going backwards in time right now, right?
Yeah, I want to wind back a little bit just to sort of show it at sunrise. So they'll enjoy more of the process of the moon moving onto the sun's disk. So really between the time it rises shortly after 5 a.m. and about 6:45 is you'll get the bulk of the show. If you go to, say, Halifax, then again, you've got, pretty much the entire eclipse, I think, from beginning to end. Yeah, it's just making first contact as the sun rises, and then you can follow along to max eclipse for you, about 80% of the sun, depending on where you are, and then an hour later. So it's about a 2-hour process for a solar eclipse from a range of locations. Any other questions in the chat, Jen?
There was one quick question that is not necessarily eclipse related, but sort of. If you're a satellite on the other side of the moon, have any satellites orbiting the moon ever looked back at the Earth and taken pictures during a lunar eclipse? So like, could you see the red ring of light around the Earth from a photo taken from the moon?
I imagine there have. I don't remember at the top of my head whether that's happened. There are satellites that are, geosynchronous satellites that stare at the Earth that have captured the process of the moon's shadow sweeping across the planet, which is really interesting.
That's cool.
So yeah, if you were to say do a Google search of satellite view of eclipse, then I'm sure you'd find examples of that.
I do have a visualization, but it's not an actual photo. I haven't been able to find anything in the quick search. Sorry.
All right. So hopefully that gives you a sense of why this is all happening. Let's talk about let's talk about viewing the sun. So I'm going to bring up a PowerPoint here that I have. So let me just slideshow from the beginning. And I'm not going to run through every one of these points, but basically the idea here is there are a number of different techniques that you can use to view the sun safely from home. And some of them require, if you want to buy equipment, you can do that. But there are some, we'll show you some things that you can make at home to do it that way. So these sort of in order of complexity, you can make a pinhole projector using a box and a piece of foil or a juice can lid. There are ways of projecting through a small telescope, but I don't recommend that for people who aren't expert at that. Welder's glass is not something that's commonly available to people, but eclipse glasses are. So we'll hold up our eclipse viewers and our eclipse glasses, and
yours are actual glasses.
Show you what these different things can provide you when we get into it a little bit here. Then you can equip a regular nighttime telescope with a solar filter, and then you can also buy a dedicated telescope that's designed to look only at the sun. It's not safe to look at the sun, the uncovered sun with unaided eyes. Sunglasses will not work, as you've learned by watching Jenna's videos. And you can't, if you're going to put filters on any optical aid, they must be properly accredited filters for the purpose of cutting the sun's light. And we'll get into a little bit more information about why that is in a second. So yeah, your eyes do not have pain receptors, so you can be damaging your eye and not realize you're doing it by looking at the sun. But you will get those terrible, you can blind yourself, but you can also create terrible permanent scarred shadows in your eye and things like that.
I made that mistake.
Yeah.
That's why I was so adamant about it in one of those videos. I looked at the partial eclipse through the clouds because I was like, how bad could it be? I've looked at the sun through the clouds before, and I ended up with a crescent in my view for 3 weeks. So luckily no permanent damage, but still not a good idea because permanent damage is very possible. Yes.
Through here, again, don't use this telescope on the sun. There are times where it's cool to say, look at the moon in the daytime. You can certainly do that. But if you've got youngsters around, you really have to do parental supervision because you don't want to risk anybody accidentally swinging the telescope past the sun or pointing it anywhere where the sun is, okay? So if you're using a telescope outside or binoculars outside, it may not always be obvious to you because you're just used to it, but there might be people or kids that aren't aware of it and that could inadvertently aim in towards the sun. So please be ultra careful about that. I'm not going to get into too much detail about the sun's science unless somebody's really, really keen to know about it. Let me just advance along here a little bit.
While you do that, Paul also pointed out that, yeah, using during an eclipse, you can, like the gaps between the leaves in the tree act as tiny pinhole cameras. So all of the shadows are crescent shaped, which is really cool.
Yeah, we're going to talk about stuff like that in a sec here. Yeah, so all kinds of really neat tricks you can do to take advantage of the eclipse. Here's just a quick breakdown of the sun's basics. So the disk that we see is not a solid surface. It's just the point where light becomes opaque. It's kind of like the edge of a cloud. The cloud looks like it has a boundary, but an airplane could still fly right through it. So that's called the photosphere. Then we have the various layers of the sun's atmosphere and the corona around it. And some of these are only visible during a total eclipse where the photosphere is completely blocked. So therefore we can see the prominences extending beyond and the corona extending past as well. Here's a neat one to talk about sunspot cycles. So the sun actually varies up and down in its activity. Mainly it's to do with its magnetic field winding up and getting tangled up and producing releases of energy towards us. And that will produce a corresponding increase and decrease in the number of spots on the sun. And so we've just come out of a lengthy minimum where the sun was quite boring, but already the last couple of months, there's been lots of spots starting to show up in, in ones and twos. And that'll only increase over the next few years. So it takes about 11 years for the cycle to peak and then decrease again. And then that cycle repeats in a negative sense. So the magnetic field winds up in a positive cycle, and then it'll release and wind back in a negative cycle for a 22-year total sort of linked end-to-end cycle. So we've just finished coming off the minimum, and we're going to be heading up into cycle 25 here. And here's an animation that's showing you what's going on. So the sun is a fusion reactor. It's not a solid body, and it's rotating. Sun takes about a month to rotate on its axis once. And that's why we see sunspots travel across the disk of the sun a little bit every day. And they'll disappear around the edge. And so as the sun rotates, that magnetic fields can get wound up and tightened up. And that will produce some of these violent releases of energy when the magnetic fields need to relax some of that stress of being wound up too tight. And so we think the sun winds up and up and up, and then it releases itself, and then it's quiet for a while. And that's why we get the 11-year cycle. And of course we care, because when the sun releases the energy, if we happen to be in the line of fire, we can get a lot of electromagnetic interference. We can get charges being laid onto our power grids, overloading our power grids. Our astronauts can be in danger if they're not protected. We do have the Van Allen radiation belts around the Earth, but everybody wants to be aware of what the sun is up to so that we're not caught unawares by some of these bursts. And this diagram here is a top-down view of the solar system from above. And the colors, the intense colors, are the bursts. So because the sun is emitting the blast while it also is rotating, they emanate into the solar system almost like ripples in a pond spread out. And in this diagram, you can see the little circles. So we've got Mercury, Venus, and Earth here. So Earth is the yellow one. So here's Earth. And then we've got these two boxes here are satellites that we park on the other side of the sun to warn us when sunspots are developing over there. And that way we know when they come around in our direction to be ready.
So cool.
Yeah. And there are websites where you can find the sort of daily diagrams that these folks put together. I'm not going to go into this, life cycles. All right, so let's talk about ways you can safely view the sun.
Ooh.
So the most accessible and terrific, inexpensive way for folks to do that is with the Eclipse glasses. So the Eclipse glasses will not magnify the sun. So if there is a big sunspot on the sun, if you've got sharp eyes, you might be able to see it just with these. You put these on over top of your prescription. If you wear prescription eyeglasses, then you wear these on top, so you get the benefit of the good eyesight, but the filter. And the proper way of using these is to not be looking at the sun, put them on, then look up at the sun, have a good look, and then look away before removing them. Sometimes if you don't explain that to people, they'll take them away while they're still looking at the sun.
And that hurts.
Yeah. And I see, Jenna, you've got the square type.
So these are available. I just posted this link in Zoom, and I'll add it to YouTube as well. These are from Sky News, and you can grab these for like $3 plus $2 of shipping on their website. And it's really, really easy. You just hold it in front of your face.
Yeah, and the one thing that I want to stress to everybody is they're an investment. Once you've got them, keep them. Because anytime that you hear in the news there's a big sunspot or something, pull out your Eclipse viewers and head outside and see if you can spot it. Yeah. You can do that with those. Really so I never have mine put away too far. They're not in the back of the drawer. They're in the front of it.
Yeah, you never know when you might need them. And we will be selling, I believe, as we get closer to the 2024 eclipse, which is a bigger eclipse, we'll be selling like hard plastic ones, we hope. And those will last you longer than just like the paper ones.
Sure. So these aren't really designed for you to stare at the sun for minutes on end. So try to limit your time that you're looking at the sun. They will cut 99.999% of the sun's light. So that makes it dim enough to view. Now, some of them, the ones I have here, will make the sun orange color. you're not actually seeing the sun's color. You're just actually seeing the function of the color of the filter. I'll show you in a minute. I'll show you another kind of filter that just makes the sun a dim white.
I was going to say, I think these are dim white, but I'm not great with color. And on that note, actually, we had a question from Janice. Is it true that the sun is actually green? And interestingly enough, green is like one of two colors that a star can't be. Just because of the way light is emitted, it can go from like blue to yellow to white, blue to white to yellow to red, but it can't be green or purple.
Yeah, the light emitted by a star, if you plot a graph of intensity versus color, there's a big hump, near the visible spectrum. And the hump is not a peak. The hump is it's flat at the top. So that means that all those different colors are all relatively equally in intensity. So there isn't really a case where one dramatically outshines the other colors. Mm-hmm. So generally speaking, you can get a little bit of shift left and right on that graph. So you can get towards the blue or towards the red or orange color. But mainly it's kind of the white is what you see. So it may peak in green, but because the adjacent wavelengths are almost the same brightness, you get that mix of colors that gives you the white. Mm-hmm. So technically you're right, but in practice, it doesn't really work that way. So when you've got the eclipse glasses, here's what you can see on the sun. You can see a large sunspots. If there's an eclipse, you can see the shape of the eclipse. If there's a transit of a planet, so there won't be another Venus transit until about 90 plus years, but Mercury does transit the sun every now and again. So if there's a Mercury transit, you might be able to see it. But you will not see any of the surface details of the sun or the solar corona with eclipse glasses. And as I said, the welder's glass number 14. So welder's glass comes in darknesses. Number 14 is sufficiently dark. It needs to be that or darker. But we don't typically recommend it very much just because they're glass, they can break, and eclipse viewers are much more economical and easy for people to have. They're cheap enough that every member of the family can have a pair and everybody can just look at the same time. Whereas
Welding glass was a good solution back in the day. I can't believe I said that, but like when we didn't have easily available solar viewers, it was a good solution, but we have much safer stuff now.
Yeah. So pinhole projector. So this is one that I made. I happen to make maps for a living. So I have these long boxes. So what I did is I got an orange juice lid and I poked a small hole in it. And then I taped it firmly on the end. And then at the other end, I made a hole and I mounted a piece of white paper in the bottom. And if you aim the top of the pinhole towards the sun, it'll project a little sun disk at the bottom of the box. And so everybody can sort of stand around and look inside the hole and see the sun. Now, of course, this will also show you the shape of the sun if it's a crescent for an eclipse. So it will magnify the sun a little bit. You can stare at that piece of paper all day long if you want to. There's no danger at all. And again, you can see sunspots if there are any. You can see the shape of the eclipse. You can see the transit of a planet. But again, no surface details or the solar corona. Telescope projection, I don't even want to go there. It's not something we recommend. So let's pass.
I did post a binocular projection thing from timeanddate.com in the chat, but we're not going to recommend it technically because it is dangerous and you can melt stuff. So no melting.
Yeah, the problem is that you can, if you were to do that, you can't guarantee that somebody unknowingly is not going to grab the telescope and look into it.
Yeah.
And it's just not worth the risk. And the other thing is that if you let unfiltered sunlight into your telescope or your binoculars or even your camera, it doesn't take long for things to start melting inside and breaking. So I'm going to actually touch on that again here in a minute. So what we astronomers do, the folks that commonly want to look at the sun, is we get a full aperture white light filter. And a white light filter is just one of those filters that diminishes the sunlight by 99.999. And it doesn't have to be as big as your telescope. It can actually be a smaller filter. with if you make one of these arrangements with a main cap and then a sub hole in the cap. So basically you take a nighttime telescope and you equip it with this, it's kind of a film. And it's the same kind of material as in the Eclipse glasses. It's just shiny instead of a dull dark. And the trick about using these is you want to buy one that matches the diameter of your telescope. You also want to make sure that it's affixed firmly so it can't get knocked off accidentally, either with wind or somebody brushing against it, or even a curious person pulling it off. Because if anybody happens to be looking through your telescope when somebody pulls that off, you
There
can
go their
damage
eyeballs.
Yeah. So I even have some of us that do outreach with these will actually tape this on or do something extra just to make sure it can't be removed. Now, if you do this, it's great because you can magnify the sun's image safely and use all your regular eyepieces and magnify the sun different amounts and do all that kind of thing. But you want to watch out for this guy.
Oh.
Because if you leave your finder scope on, you can damage your finder scope if you don't have it capped.
Oh no.
So typically what we would do is we would take these off when we're using it for the sun, so that can't happen. And you'll notice that there's a little contraption here at the front. So there's a little pin, there's a tiny hole. The sunlight goes through the hole and illuminates a little piece of paper at the back. And you just line this up so that the pinhole image of the sun sits in the bullseye, and then you know your telescope is pointed at the sun. So that's the white light filter. So what's great about using it for that, it suppresses all the wavelengths, attaches to the front, lets you magnify the view of the sun. It's completely safe for continuous viewing, and that will let you see the sunspots, even the small ones. Now, sunspots, when you see them, they're not just black and white, solid dots. There's some texture to them. I'll show you that in a minute. Eclipse shape changes. Again, no surface details, no corona. I keep saying that. All right, now here's where the real fun comes. Viewing the sun in hydrogen alpha light. So the sun's spectrum, as we talked about, covers a range of colors. And those colors are all derived from atomic processes. So atoms that are receiving and emitting light. And as a cohort, they're generating a spectrum across the range of colors that combine to produce the bright white sun that we see. And one of the main colors that we like to focus on as astronomers is the one that's given off when the hydrogen atom, which is the proton and electron, get energized. And then when the electron relaxes into the hydrogen atom, it gives off a wavelength of light in the red part of the spectrum. It's called the H alpha spectrum. And it's at a wavelength of 656 nanometers in the red part. And so what's cool about that is that if you only looked at that kind of light from the sun, you'd be seeing all the stuff the hydrogen's getting up to on the sun. And there's a lot more interesting details visible in that hydrogen alpha light. So we design telescopes that are designed to look for that kind of light. And that's what these are. So this is called a personal solar telescope made by Coronado, or you can see there the name there. And you notice that it's really tiny. That's because the sun is bright. You don't need a big aperture to look at the sun. You just need a little aperture. The only thing that aperture buys you is the wider your aperture is, the more resolving power, more resolution you get in your image. But for brightness wise, even a little tiny aperture telescope is fine for the sun. So these are kind of entry-level solar telescopes. I think they're probably around $700, give or take. I actually bought this one used, and this one is the best solar telescope I've ever looked through. I've looked through lots of them, and I just got lucky. I got a real gem of one. And the way they work is that,
like the best out of all the Coronados, you mean?
Best of this type, yeah.
Oh, wow.
So the light comes in from the front. When it gets to here, there's actually a dial in here, and there's a pair of sheets of filtered glass that are designed to only allow the certain wavelength that you want through. Then the light passes through here, and then there's an additional filter in here that continuously makes the light dim enough to look at. So this will produce a red view of the sun, a red looking sun, because you're using the red hydrogen alpha light. And the reason that you have a dial here is because the sun is rotating. And so that you get a Doppler effect. You can get parts of the sun that are moving towards you and parts that are moving away from you. So the wavelength of that hydrogen alpha light can vary a little bit. And so you can use the Doppler effect, or the, it's called an etalon. You can tune it to see the different structures on the sun.
That's cool.
So let me just show you. This will show you the sun's surface features. And so here's an example of some of the things that you can see in hydrogen alpha. And it's just a diagram showing how the sun can be really quiet when the cycle is low and be really interesting and dynamic and cool looking when it's busy.
I have never seen the sun look that cool, but that's because I've only been looking at the sun for like 2 years.
You need to look through my PST. We'll make that happen.
Someday.
Yeah. All right. So here's what you can see if you have a hydrogen alpha telescope. And I know that it might seem inaccessible to many people, but hey, if you go to a RASC event or star party, we do have solar as well as nighttime events post-COVID. So, you know, look for those golden telescopes and head on over and get the hydrogen alpha.
If you're in Toronto, and this is all post-COVID, a group of Toronto volunteers often goes to the Science Center, the Ontario Science Center, on Saturday mornings and does solar viewing, and it's great.
Now, just to make everybody drool, so RAS Toronto Center also has one of these. This is a Coronado Solar Max 3 telescope that we bought to use during outreach at the David Dunlap Observatory. And again, it's got a bigger aperture, so we get a little more detail in the sun. And unlike the PST, which is basically not something you can easily put a DSLR on, this has a full focuser and all of the mechanics of a regular refractor that you can use to put a camera on this and capture images. So.
Oh man.
So.
We'll
get there soon.
Someday.
All right. So let's talk about some of the cool things that you can see on the sun. So here's the sunspots. In the white light, the dimmed white light version, you get the sun looking black and white with the sunspot groups. And this is when the sun is well into its cycle. You can get lots of spots on a given day. And then if you zoom in on them, magnify them, you can see that there's a dark center and then a halo around the edge. And here's the size of the Earth for comparison, this little circle down here. So they're gigantic. And what they are is they're places where the sun's magnetic field has been tied up in knots. And that magnetic disruption prevents the heat from the sun from exiting. So the energy from the sun is continuously emanating from the center out to the photosphere. When it gets to the photosphere, then it starts to travel through space to get to us. If anything blocks that heat from coming out, then the sun is cooler in that spot and it looks darker. So a sunspot is really just a cool patch, a dark, lower temperature, cool patch, also cool, but cool in both senses, on the sun. And so if you have a nice telescope that'll magnify them, you can see these dark cores and these nice halos. They tend to come in pairs because they're magnetically polarized. So there's a north and a south. And they'll actually migrate and change their location on the sun's disk from the polar to the equatorial region at different parts of the solar cycle. So they're really cool.
When you say they come in pairs, do you mean two spots right next to each other, or one spot on one side and one spot on the other side of the sun?
No, right next to one another.
Okay.
So there's kind of a magnetic loop connecting the two spots, kind of a bridge connecting them. Yeah, good question. And we number them. So the satellites that are on the far side of the sun are keeping an eye. As soon as one forms, they'll give it a number and they'll wait. And then after a number of days, it'll rotate into view for us. And then it'll take, a week or something to pass the sun's disk from left to right or east to west, and then it'll disappear around the edge. What you can also see in a good solar scope are the granules. So you can see that the sun has a mottled texture, almost like an orange peel. It's not smooth. And each of these little blocks here are a convection cell, and they can be as size of Ontario, one convection cell. So they're gigantic. So they have a hot center and then a cool edge. The material's upwelling, hot material, and then cools. and goes down just like porridge boiling in a pot.
I was going to say that I always thought that looked like oatmeal.
Oatmeal, yeah.
Yeah.
So those are the convection cells. Let's see, province side. Here we go. So plashes. So plashes are hotter, brighter areas around sunspots, and it may be a fact of that heat not able to come up through the sunspot, so it escapes out the side and brightens up the area surrounding the sunspot. And they're called plage because in French, plage is beach, so it's kind of like a white, brighter area. And so you can see in this diagram, I've got a dark sunspot and then a bright, halo kind of thing around it. So now these dark little strips are really neat to see in a solar scope. They're called filaments. And what they are is material that has been lifted off the sun's surface, and they're suspended in the air, suspended not in the air, but in the sun's atmosphere above it. And because they're off the photosphere, they're a little bit cooler. And so when they're cooler, they're darker. That's the rule of thumb. Cool means dark when it comes to the sun. And so they tend to form these long sinuous strips because they're following magnetic field patterns on the sun. Now, when we're seeing them on the sun's disk, we're looking down on them. But when they're on the edge of the sun, they stick out. And so that's what prominences are. So
we had a question on YouTube about those and how to view them. So I'm glad you got to them.
Yeah. So prominences and filaments are one and the same, and they're not flares. So people call them flares, but they're not flares. So prominences can be long. They're huge. They're 10 Earth diameters in length, that kind of thing. And what's neat about prominences is that they're like elephants grazing. They kind of, over many minutes or an hour, they change their shape. So you can watch them kind of move and change. They also come in all kinds of different styles. You can see them. They can look like Christmas trees or flags or hoops or any kind of shape. So you never know on a given day what you're going to get. So investing in a solar telescope, if you've already, for the person that has everything already, a solar telescope's not a bad investment because you're up in the daytime. Yeah. It's ready to go. You just need to aim it at the sun, put it on a little tripod. Doesn't need to track the sun very, very well because the sun's easy to find. And there are lots of times where I go out every day and look at the sun.
Oh no. Two quick notes. Specifically, I've already forgotten one of them. But one of them was going to be, if you want to see prominences, all you have to do is look around the edge of the sun using a solar filter. But the solar filter has to be hydrogen alpha. It cannot be white light. White light filters will not show them. Correct, Chris?
Correct. That's why I said at the beginning, can't see the corona, can't see the surface features. Yeah.
Double checking. And then if you do have a solar telescope and you have a camera attached to your solar telescope, if you take photos of of prominences over long periods of time, you can create time lapses of them moving, and it's very cool looking.
Yeah. So they can actually be video. I mean, it could be a video for a few minutes and you can see some things change on the sun. All right, so what you'd see.
Question before we move on. Sorry, before we get too far in, or it's okay, we can keep going with the PowerPoint slideshow. But there's a question from Odontomatics. Do all stars have these features like plashes, star spots, magnetic field dipole pairs, and stuff like that?
We think so. There are different types of stars. You remember when Betelgeuse dimmed?
Yeah.
In the winter of 2019. And some people wonder if there were sunspots on Betelgeuse that rotated into the side facing us, and that contributed to its dimming. We haven't imaged very many stars directly, but it does appear that we're starting to become able to do that. And I think we'll be picking up details like that, if they're big.
Yeah, it's tricky because, we can't really, we're really, really, really close to our sun compared to all the other stars out there. But almost, as I've said multiple times, almost every discovery in astronomy has been, we're not special. So odds are prominences exist on other stars.
All right, so let me just, before I go on, I just wanted to touch on a couple of other things that you mentioned, one of them, and that is that during an eclipse, anything that's got holes in it will project the little crescents. So you can just poke a hole in a piece of film or a piece of paper. If you've got a colander or a strainer, if I hold this up, it'll make a bunch of little crescents. Or you can look for the holes between the leaves and the tree.
Yeah, just a heads up as well for this eclipse. This eclipse is really tricky. Like both this solar eclipse and the lunar eclipse, I have like, I don't want to outright say they're just kind of meh, but they are kind of meh. Like they're not as great as they could be because the solar eclipse is happening right at sunrise. It's already mostly done, and the sun is often blocked at sunrise by things like trees. And if you're, you know, near mountains, then mountains. So it is tricky. And on that note with shadows, I mean, we don't like, it's kind of hard to see shadows at sunrise sometimes.
You're almost going to need to be wearing a white t-shirt and projecting onto your
Or
shirt
like,
or something.
if you have your colander and then you have, oh, is there anything on this plate? If you had, like, you'd have to hold something white up instead of having it flat, which is what everybody shows. It has to be upright, which is like kind of tricky. Anyway, so it's a little difficult. Not saying you should not observe, but like, it's a little tricky.
I won't be setting the alarm. I don't think so. Maybe. We'll see. We'll see. Yeah, but consider what you know, every opportunity is cool. If you get some practice at it, then it'll prep you for April 8th, 2024. When we'll get the real deal coming to.
That's like middle of the day, like right overhead for large parts of Southern Ontario, large centers of population for Canada. Yeah, this is our dry run, the practice run.
Yeah. All right, so this is what the big picture, what you'd see in a telescope like my PST. The PST will show basically the whole disk of the sun all at once. And then you can tune it to enhance or bring out any little prominences. They can be like little fuzzes sticking out, or they can be more substantial. If we're lucky, we can get some of these long filaments along the edge and then sunspots coming out. So this is the sort of view that you get in a solar scope. And I've seen something much like this in my PST. So, you know, if you're interested in looking at the sun, it's a pretty good investment, a little solar scope like that. You just can't use it for anything else. It's just for the sun.
You're making me want to buy one. Like,
yeah.
I didn't think I was gonna, because I always kind of, I don't want to say poo-pooed like solar viewing, but it was like solar viewing's like it's expensive and it's, you know, I don't know if it's for me, but this is all looking really cool and there's so many things to see.
Well, I haven't regretted. I did buy mine used, so I got a bit of a better price. And you can certainly do that. And don't forget that if you're a member of a center like the Toronto Center, we have several PSTs that we loan for free to members.
Yeah.
You can keep them for 2 weeks and look at the sun. And then if you decide you think it would be worth it. But what's cool is that if you're going to the cottage or a barbecue in the summer in the daytime, and you're the person that brought the solar telescope, I mean, you're popular.
That's true. You always have friends. Yeah.
It's not so easy to get people out to the telescope at night in a situation like that. Mm-hmm. But in the daytime, it's terrific. All right. So here's just a quick example of the difference between the solar filter, the white light on the right here, and the same view of the sun through the the H alpha. So you can see the spots, the same spots are here, but you get a little more details revealed by the H alpha.
Texture and stuff.
Let's see. So there are websites that you can, I think this is about the end. Yeah, let me just finish this up. I'm just going to show you the space weather website. So if you're curious as to whether there's anything going on in the sun, I usually look at spaceweather.com. And then there's on the left-hand side, there's a thumbnail showing today's sun. And if you click on it, then it brings up, there's the sun today and there's the spot. So I actually saw this spot. There's actually one big spot and one little spot. I saw that today using this.
Oh, yeah.
This is called a sun spotter. And what this does is it's basically a projection through your telescope, but without the tube of the telescope. And because it's all folded with mirrors, nobody can get their head in there and blind themselves. So the sun goes in the objective lens, like a refractor telescope, bounces off the mirror in the back, bounces to another mirror, and then there's a little eyepiece that's built in here that projects the sun onto a piece of paper. There's a piece of paper. What's great about that is that a lot of people can all stand around and look at it together. Mm-hmm. So it's cloudy where I am right now, where I can take people out and show them the sun that way. But
that's too bad.
So I think I think that was all the main things that we wanted to talk about. Let's see.
On that observing thing that you have, which I've already forgotten the name of, the one with like the wooden thing, that is available from the Astronomical Society of the Pacific. It's probably a little late now to be buying it for the solar eclipse, but you could use it to see the solar eclipse. In theory, if the sun is not too far down on the horizon for you to really point it at the thing. But it's also great for kids because then again, low risk, lots of kids can see.
Yeah, but don't forget that we're just beginning a solar cycle. So we've got at least 4 or 5 years of really cool sunspots to look forward to on the sun. So that would show them in a great way.
Mm-hmm.
So, and they are a little pricey. They are a little pricey, but
Yeah.
if I had the choice, if I were going to spend $600 or $700, I think I'd buy the PST versus the solar scope, the
Me
sunspot.
too. We have a few little questions, but nothing huge. If you have other questions, please toss them out into the chat or elsewhere into the Q&A. One question from Dave Erling, and I don't remember the series of letters and numbers that you're looking for, but what standard do solar glasses have to meet to be safe? There is a standard, and I can't remember what it's called.
It should be, I think it may be on here.
I know that ours pass it because I had someone who is an ophthalmologist and who is the past president of Toronto Center tell me that ours passed it.
Yeah.
But I don't remember what it's called.
It's an ISO number.
So there is a standard though. There's a standard for
ISO,
sure
you want it? I'll tell it to you.
Sure.
Here, let me just put it up to the camera. Can you read it?
Oh no, ISO 12312. Oh, I've got the Q&A in the way. 2015, 22015 at the end. Oh man. So there you go. That's the standard.
So that's important. If you're buying from Amazon or something like that, you want to be buying from a reputable dealer because you can't just take any dark plastic and make a solar eclipse view out of it. It has to be something that's going to block the visible light and the ultraviolet.
Yeah.
The ultraviolet light will penetrate through.
I've also been told it has to block infrared light by James Edgar, who edits the handbook, the Observer's Handbook. It has to block infrared light too, because infrared light can also damage our eyes. Pretty much any like UV, ultraviolet and infrared, ultraviolet, visible, and infrared can hurt our eyes.
Okay, here's let me just bring this up here. Just for benefit of people that are looking forward to April 8th, 2024.
Oh yeah.
So here is the total eclipse visible from Toronto. And it's not total, it's 99 or something from Toronto.
Yeah, it's 99. Like the path goes through Hamilton.
Yeah, so let me show you let me show you how to do these maps. So if you go to EclipseWise, this is really useful. Scroll down to where it shows all the different eclipses. Go to April 8th, 2024, click on that. And then go down and look for Google Map of the total eclipse. And then just zoom in.
Oh yeah.
And this will show you the cities, the towns, even the neighborhoods. Let me just get us out of the US and up to Canada here. Okay, here we go. So
look at that, we're so close.
Yeah, and here we go. Here's Toronto.
Ah!
So if we have friends, a number of us have friends in Hamilton or Trenton or Prince Edward County, Kingston. Yeah. They'll be able to see the total eclipse, the totality. Now, if you're on the center line, you get the longest duration of totality. And in fact, I believe you can click on here. So Buffalo, New York, you'll get, let's see here, 3 minutes and 45 seconds. Oh, nice. Okay. If you're in Kingston, though, 3 minutes and 3 seconds. So the closer you are to the edge, the less totality duration you have. If you're in, say, Belleville, it's down to 2 minutes. So it really is worth the effort to get yourself to the close to the center line as you can. Bear in mind that it's April,
Yeah.
so
So it might be cloudy.
there's no guarantees it's going to be a clear day.
Yeah.
And in terms of where in the sky it will be, so this is the eclipse peaking around 3:19 p.m. in the afternoon, nice and high in the sky. It's, let's see, 45 degrees up in the sky. So
Oh, that's
perfect.
perfect.
So we'll definitely share a number of really cool things that you can see during a total eclipse for people.
Yeah.
I went to the one in Wyoming in 2017 and I saw I was blessed to see all of the cool things that they said you would see.
Oh,
So
really?
I
You got to
didn't,
see like the Bailey's beads?
I got the
and...
shadow bands and the Bailey beads
Oh,
and like the snakes on the ground and the shadows getting all weird because you're getting the sliver of sun.
that's so cool. I didn't know
And the
about that
temperature
one.
dropping, all the things you hear about
Oh,
are
wow.
true. They all happen, and it's really a once in a lifetime thing. It's worth it's a bucket list thing.
It's a
You can
bucket
make
list
it,
thing for
you
sure.
should do
So
it.
a couple notes on that actually in terms of best places to view. Weather certainly comes into play. And so I know for a lot of RASC members, they're going down to Texas because Texas is more likely to not have snow in April than most of Canada. I do know that there's one RASC member, I don't know if he's a RASC member, but he's an astronomy outreach guy who is going to be at the Fogo Island Inn in Newfoundland because Newfoundland is on the path too. But I don't know about Newfoundland in April. I have been in Newfoundland in April and it has snowed, so I'm not sure. A lot of it does come down to weather for eclipses and the odds of it being good weather.
Yeah, one thing that Fred Espenac does for NASA as part of his work is he actually produces a book for each eclipse, and he actually puts in there historical weather patterns and maps of, probability of cloud cover for different parts of the country and things like that. So it's not a bad investment if you're planning to take in the eclipse.
And it's also helpful to, I have never like seen a total solar eclipse. I have never imaged a total solar eclipse, but it is helpful, I have heard, to practice in advance if you do plan on taking pictures, because there's this whole, like, when you're doing a total solar eclipse, also a reminder that's not what's happening on June 10th. But if you are taking pictures of a total solar eclipse, you have the solar filter on until the last second and it switches over to the actual totality part. Like as it's partial, you need the solar filter on and then you need to pop it off and change the exposure so that you can get the corona. It's all very complex and it's worth practicing. So
yeah, there's kind of a choreography to that for sure. When I was in Wyoming, I used an app produced by a gentleman named Gordon Telepun, and it was an app that was designed for the eclipse, for the 2017 eclipse. And I know he's produced one for the 2024 eclipse. And this app actually will sit in your pocket and be like an eclipse expert in your pocket, and it'll shout out to you, eclipse glasses on, eclipse glasses off, do this, do that, count you down to the totality. It figures out where you are and does all the math for you. And it's really a worthwhile thing to have. So
that's really cool.
it's cool.
Oh,
yeah. So I see somebody had a question.
So there's a question from Peter Brackett, which is very specific. And I love it because Peter, I know Peter's a really good observer. Can Chris comment on the shape of the different eclipse paths, i.e. when the moon is above or below the plane of the earth, like when it's not perfectly lined up?
Okay, so I don't know if I can do this exactly the way he wants, but let's start with this.
Okay.
So if you go to the eclipse-wise solar eclipses, scroll down, can you see all those strips? So the blue and red strips here are the various tracks of the Earth's shadow contacting the Earth, the globe of the Earth during the eclipse. So here we have the April 8th, 2024 is this blue one. And of course it's an orthographic projection. So things near the North Pole are stretched out. So don't get misled by that. But basically the width of the path of totality varies during the course of the eclipse, depending on the geometry of the Earth, Moon, and Sun. And so you can figure out, based on that, where best to be. And you need to be within the start and end points of the track in order to be sure you're on the eclipse. Mm-hmm. Yeah, so you can see that when the Earth is low, or when the moon is high, when the moon is low, the moon is south of the ecliptic, then the shadow will go across the Earth's southern hemisphere. And that's when you're getting these ones like this. And by the way, the blue are total and the red are annular. So the total eclipse on 2021 December. So there's one this year, December 2021, that just goes across the Arctic. It's basically only visible in the Arctic. So the moon will be riding south of the ecliptic, and we can prove it in stellarium in a second here. And that'll cast its shadow along the bottom of the Earth. Whereas this one, the moon is would be to the north of the ecliptic more so, and that'll give us the more northerly eclipse happening. So when it's kind of centered, then you get these nice ones near sort of more equatorial. Hopefully that kind of explains it. Let's see. December 4th, 2021. Let's try that one. So December 4th, 2021. And the time, let's see, where's the time? Oops. I'll just close the sky here. I'm not sure which time of day it is. Oh, sorry, 2021.
Oh, there went the moon.
There it is.
Yeah.
Yeah, so from here, the moon is sitting south of the sun for us. So we don't see the eclipse, but if we take stellarium and we drive with our magic Wonder Woman plane south, the further south on Earth we go, the geometry brings the moon up.
That's so cool.
So by the time you get to South America, does it make it?
Just a tiny bit.
Just barely. So this eclipse would be visible. You can use stellarium to figure out, what each place will see. So when you're at the equator of the Earth, you're going to see basically a little of the eclipse, and then the farther south you go, the more eclipse you get. But even in sort of Argentina, they won't get a total eclipse. They'll get
almost
partial. And in order to see the total, you need to get right down to the Arctic.
Oh man.
So yeah, I think that would explain what he's driving at.
I think
just
so,
based
yeah.
on the way the geometry works. So
there's also a question from one of our attendees in Kelowna. Would you be able to show us what the lunar eclipse tomorrow morning at 4 a.m. Will look like from Kelowna?
Sure, let's do that. So let's go down to now and bring up the Earth and sky. And let's see. And we want the moon.
And this is the moon tomorrow morning.
Yeah. So we want to be actually opposite the sky from the sun. So let's find the moon here. Here we go. I'll take off my equatorial. Here we go. So in Kelowna.
Oh yeah.
So the eclipse, so we're sitting here in Kelowna, BC, and the moon will start contacting the penumbra around 1:45 a.m. local time or Pacific time. And then you'll start seeing the bite out of the moon here at around 2:45 a.m.
Nice.
So you can either stay up late or get up early.
Depends on what kind of astronomer you are.
So yeah, the sky, you can see the sky is getting light. So we're getting the pre-dawn here by the time you get to totality. So around 4:10 in the morning.
Nice.
So you get the benefit of the whole show.
Lucky people out west.
Well, take pictures and share them.
Yeah, tag us if you do. There's a post from Jamie, I revealed your true identity. Mentioning that when he went down to see the 2017 eclipse, he took photos, but the key for him, the important part was being there and seeing it, because it's a bucket list item. It is something that only happens, a handful of times. There are people who chase eclipses, and that's all they do is they'll run around the world finding eclipses, and maybe they'll see them more. But for other folks who are, more casual about it, you do only see it once. And on that note, there was also an XKCD comic recently posted about photo topping with astrophotography, which I thought it was ridiculous. There are people who do a lot of that, like trying to get the best possible photo, like getting a rock climber in front of the solar eclipse as it's happening, which I will not lie, I have thought about. But yeah, like go and experience it and see it.
Yeah,
And
you know what? Thank goodness people take pictures of eclipses and videos for us, but don't be the person that's got your eye glued to your camera during the eclipse, or something goes wrong and you're sitting there fussing with your camera. You've only got a few minutes of totality. So, take some of that few minutes to enjoy it with your own human eyeballs, and then sort your camera out after if necessary, but don't miss it. Don't miss it.
Don't miss it. Yeah. It's sort of that like argument of when people aren't present experiencing something and are instead looking through their phones and taking photos. And I've been guilty of that for sure. But then you don't actually like experience the thing. You only take the photos of it, and then you only experience the photos.
So just head over here and just start browsing and figure out which one you want to go to. It shows you where in the world they happen, and plan accordingly.
Yeah,
so
exactly. Alrighty, I think that covers, oh, that's cool. I think that covers all the questions that we had that were relevant to solar eclipses and everything.
It's cloudy here. Sorry, folks.
We can't even look at the sun right now, but if we could, we'd show you. Or Chris would, because Chris is the only one who has solar observing of the two of us, only one with the solar observing.
I have my
material.
array here, yeah.
If you'd like, you can give us a follow on social media. We have a series of videos coming out over the next little while with little tips and tricks about solar eclipses. They cover, like, this experience, what you've seen here covers almost everything. So you're probably set. But you're welcome to follow us anyway. And if you go out to see the lunar eclipse or anything tomorrow morning, or if you go out and see the solar eclipse in 2 weeks or 2 weeks from tomorrow, please tag us in your photos, because we would love to see, because realistically, Chris and I will be sleeping.
Yeah, probably. And don't forget to look at the rest of the sky. So one of the cool things about a lunar eclipse is that all the stuff the full moon normally hides come back, right? And same with the solar eclipse. When the sun is mostly gone, then planets reappear and bright stars reappear and things like that happen. So take in the whole experience.
Yeah. All right, we'll see you all in 2 weeks I don't know if we have a subject chosen for 2 weeks from now.
We haven't put our schedule out for June. I don't know if you want to do a break for the GA, but stay tuned.
Yeah, stay tuned. We'll keep you posted on social media and that sort of stuff, and in the newsletters with Rask. We'll let you know. We'll see how it goes.
Yeah. Enjoy the nice weather, everybody. It's more clear skies. Get out there and take advantage.
Observe. Have a good time. Clear skies. We'll see you all.